So this is another form of coaxial cable where you have a number of twist wires. Right, this is mainly for internet or LAN application where you have speed up to 100 Mbps. But these sorts of cable are used only for a distance of 100 meters. If you go beyond that, the losses in the cable is quite high. So this is for short distance. This is also another type of cable where you have two wire. You have an outer copper right shield and two wire ribbon cable. This provides a constant impedance. Maybe before 20 years or 30 years, this was a popular cable for connecting the TV antenna to your booster, right, in the television reception. But today, they are all meant for only specific applications, not for the commercial applications. A more detailed diagram of that. This is another parallel two-wire line. So these wires are used for wireless communications, for connecting your transmitter to the antenna. Mainly you can see such cables in All India Radio, right, antennas, and then antennas which are used for communications in the airport, right, and such applications you have. This is also another. See, these ceramic or plastic spacers are maintained at constant distance so that the distance between the wires are not varied, they are fixed. So the distance between the two conductors are maintained constant by these spacers. And once again, we have the coaxial cable. Then waveguide, since most of you would have done the RF and microwave laboratory, you should have come across this. Or those who are in the third years, you may be doing the experiment, where the dimension of these waveguides, that has relation to the operating frequency. So this is a fiber optic cable where you have a number of glass, right, strands put in a plastic tube, and then you have a central strengthening member, and you have insulation covers, and of course you have outer plastic or PVC jacket. So you have around 5 or 6 optical fiber strands. The dimension is almost around 100 micrometers, the size of the human hair. So such fibers are put in plastic tubes, 5 or 6 fibers in each tube, and then you have a central strength member, and this is what normally they show us here for optical fiber, and you can have number of such optical fibers, right, in a common plastic outer sheath. So you have an inner glass core. So inside a optical fiber, you have 2 layers. One is called the core, another is called the cladding, and then you have a plastic jacket. A number of such things can be put inside a total enclosure. And when we talk about transmission lines, we already said that they are all meant for connecting the source to the load, and also to effectively transfer the energy right from the source to the load. Here in this slide, this is how you have a transmission line connected to the source. In the case of a coaxial cable, the case of a parallel wire. And here in the case of a microstrip line in a PCB, you have a ground plane and you have a top conductor separated by a dielectric slab. And then you have a example of unbalanced line, ground, and then you have a conductor. So the most common type of waveguiding structure, as I told you earlier, a waveguiding structure is that when it carries signal or power from one point to another. Transmission lines, fiber optic guides, and wave guides. These are three commonly used structures.